Oh shit. Hello. Oh boy. Oh no. Okay. I said before, I generally have no space for my microphone. It's tragic. I need a bigger desk. But anyway, today I'm working on this. Oh yeah. So, where's my mouse? What the hell? Yeah, so I'm working on this library again. For those who don't know, I've been working on this library for a long time. In fact, I can't even remember when my first commit was at this point. Here it is. Yep, the binary CPP library. It's just, okay, I guess it's 7 months ago-ish. It is a library for C++ 23 and newer. Well, really the latest version of C++, but right now it's 23. To make working with binary data easier, like binary files and stuff. So I kind of need this as a precursor, as a prerequisite for my XFBin library. XFBin is a proprietary video game file format for the CyberConnect 2 games using their own custom engine. It's a file they use, and to more easily edit that file's data, I have created this library, this binary library, which is more, general purpose. So I had a working version before, but I wasn't really happy with it, so I want to refactor it. And yeah, so I have these 3 examples to kind of show how it works. This is currently not functional, but it's just like to get like ideas going. Unfortunately, probably the biggest issue here is error handling. Unfortunately, compared to Rust, C++ still isn't as ergonomic. We are getting pattern matching eventually, TM, but that could be like another 6 years before that's like fully implemented. So in the meantime, we're stuck with this stuff. By this stuff I mean we're stuck with overloaded, tragically. What? Overloaded? We're stuck with standard visit is what I mean, tragically. But as you see here, you just include it. It's a very simple header include under the namespace Kojo, and then it uses results types as opposed to exceptions. So, for example, you would call the constructor you were not calling constructor. Instead, you would construct via a function. So binary load from path. If you apply that to some argument, a path, right, a string, whatever, then it will load it. If it fails, then this will happen. So if not maybe data, if it's failing the maybe check thing, whatever, then you can it will check what the error is. And the reason I have this as opposed to because I could just make it an enum, like found not found enum, but instead I have it as a struct so that you can access specific data. Like here you have error dot get path, so that will store the path in the error so that you can print it, right, for more details. I also have a method called for as string. So instead of you having to manually do this, could not find file, a path, whatever, it will just do it for you. So yeah, that uses standard visit syntax because that's the best we have right now until the pattern matching comes. And yeah, so that's it. That's how you load a file. I'm very happy with that. But for actually using the library, so for reading, my first thing I'm wondering is, do I have reading part of the binary class, or do I have the binary class only be used for storage, and for reading you have to use a binary view class? Because binary view is non-owning, it just uses a pointer to kind of go over it, some data, but the binary class is owning, it owns its data. The good thing about giving the binary class binary view functionality, so reading functionality, is that you don't need to have 2 instances of a class, right? You just have one. You can just have one, which is obviously more optimal, performance-wise and whatnot. But anyway, suppose you have some data that was read-only, then you can put it into a binary view, and then you would do this. So there'd be a pointer inside, and each time you do a read method, like read int or read string, this means that it'll read 4 bytes of the string. Then it will store it here, and if it fails the operation, then you can check it like this, and you get an error. So that's that. There may be more specific error details here, but otherwise you just do this. Now, yeah, I guess that's it. And then, I mean, in Rust, you'd have like a question mark here, so if it fails, it would like propagate the error outside the function. Maybe I can do something like something kind of set up like that, but whatever the case, this is fine as well. Some people may disagree with having the pointer be implicitly incremented. So again, for the read method, it will automatically increment the function, the pointer by the size of the data. So here, because read string is 4, like here I have read u32, which is 4 bytes, right? So both of these will increment the pointer implicitly by 4. And the other way you know that is by knowing what read does. I do have an alternative function. Is it here maybe? No. I will offer an alternative called peek at. So instead of having just read string, you can also do peek string at and then have an address as well. So if you want to like specifically do that explicitly, you can. That's fine. And that will not increment the pointer. So I want to have both options there, but the intention is that by incrementing the pointer automatically, it's just more convenient, because you usually only, because like you usually want to go through a file sequentially, right? Yeah. Here you can see I got like standard endian. Setting that for this, you can, since it returns a standard expected object, you can use the methods there, like value or is part of the class there of the standard library. Sorry, so that's cool. I do wonder for endianness. For endianness, I do wonder if I also have a function that sets the default one, because like right now you need to explicitly state for each single read if it's big or little endian. If you don't know what endianness is, look it up, I guess. But maybe I just have like a default like set big endian, and then I'll just read it like that. But I don't know. I did bring this up like at least a year ago to other people, and they suggested to have it explicit. But like, for example, like 010 editor, my favorite hex editor, it has a set big endian. Oh, sorry, well, not set, but like it's like a big endian function, like a little endian function, as opposed to doing it here. So I do wonder. Then what's this here? Some handle error function, or else handle error. Yeah, exactly. This returns what? Expected. Yeah. I mean, again, like the ergonomics are just better in Rust, and I did actually want to make all this xfbin stuff in Rust, but for the sake of other people, having it in C++ is just more flexible. So I'll do it there first, and then I'll probably rewrite it in Rust later for my own projects. But it is useful for the community, the KojoBailey community at large, to have it in C++, because that's kind of the everything language. I know Rust is as well, but Rust is newer, so it's not like it takes longer to catch on, unfortunately. Anyway, enough explaining. So yeah, I've got this namespace for type abbreviations. Got the constructors here. The constructors are not deleted, so like you can construct an empty object, that's fine. It just won't do anything. I did override copying to move instead. So I mean, well, by which I mean, hold on. Alright, so like I do have like implicit moves set up. Sorry, I was trying to remember if this is const reference, right? But this is oh my god, I can't remember this. What's this called again? The 5 something. The rule of 5. Destructure, copy constructor, copy assignment operator, move constructor. Yeah. I just forget which one is copy and which one's move. Pass by value. Yeah, so I'll just do object 1. Okay, so either way, you still have to call move explicitly, I guess. Okay, fine. Anyway, whatever. So that's fine then. The destructor is also just default destructor. It just cleans up stuff automatically using RAII. Very cool. And then you have these thingies, load from path, load from span. Before these just said load like that, but I figure that it actually is better to make it explicit. And say which one it is. I'm not a huge fan of overloading. I do think it's good that Rust got rid of it, and overloading should instead be reserved for type traits. But like for just like normal like tasks like this, like loading from path, loading from span, I think it's better to just make it explicit. So got that there. I mean they even return different things, don't they? That's a lie, but they do accept different things, which is the point of overloading. But whatever. Anyway, so that's fine. Load from path. I did consider loading from file as well, so I might add that, but for now I'll just keep it simple, have these 2 things and expand the features later. For writing, yeah, so because this is the binary class, it can also write as well as read. So for writing, you have write, and then it's a string. Now, again, before I have this fairly hacky way of doing it. Like I use standard same as string view, same as byte. Down here, it's just an integral, and they all use the write name. So like it'd be like write standard string, or write standard string view, or write standard like byte, whatever. But this is not ideal, at least for like string. In fact, for all of these, you don't really need this at all. Like let's say I want to write a U32 with a value of 10, standard endian big, right? Like if we know that this is already a U32, I mean it'd be easier in Rust, wouldn't it? But like if we know that 10, like let's say we have U32, okay, let's just do the full name. A U32 version equals 10, and then like I write version here. Like notice the redundancy between this and this. This would say standard. Like this is redundant. Whereas if I just have this, like isn't it way clearer? I mean, I'm not clear. Like it's not sufficient to just have this. And like even if it wasn't literal, right? Like I could still, well, first of all, I could probably still specify it. I think that would work. But also I could just, in fact, I think this works anyway. Like right now, whether or not you specify it. So there is that. But also like you could just make it explicit. Anyway. Whatever. Or I guess a better thing would be like this actually, where you just you construct it like this. I think this is valid C++. Honestly, I can't remember. There's some goofy features in this language. Yeah, so there's that. And then like for strings, like it's very obvious, right? Like just write hello, like obviously it's a string, so I don't need to do, you know, standard string view. Like that's just completely unnecessary. And for bytes as well, like whatever. So there's that. Now reading is a different case. So for reading, so what are these? Set endian. That's for just like that's like a utility function. Yeah. So these I don't know why I have this like this. Like size should be get size, storage should be get storage, and like stuff like that as well. Like one thing I said I would do is I'd use proper names. Like a getter should say get, you know, because like if I have, you know, like if I have well, whatever. For booleans, yeah, this is right. Like is empty instead of just empty. That's correct. So that's fine. But I do need to fix these. So let me start by renaming these. Open a new terminal window as well. Okay, get size. I mean, the original intention was to mirror the standard library, but I don't want to do that anymore because it's just not necessarily a good example. Like I have get pos, but I don't have get data. Maybe it's just outdated and I need to update it. I don't know. But yeah, set position, time position, whatever. Reading is interesting. So for reading. Oh, that's interesting. Okay, so for reading, I actually only support reading by byte using this thingy. So like if I have data, I can do like data 5, right? That's the only thing I support right now. I do wonder if I should add read, right? Like I said. But if I do add read, question is like for read, obviously I can't just like specify. It can't infer what I mean. Like what size, because like I'm not passing a value, and like write, so it'd have to be read like this then, read 332, and store it into something like that, right? I don't think this works. Like I don't think the compiler will see foo's type and then say, okay, let's read a U32. So this is fine. And then for strings, I kind of want to avoid doing like this. So honestly, I prefer to just do like this. I think that's better. Yeah. Like this should be big. Good. Sorry. And then as I was saying before, maybe have the endianness just be like have a default. So that you can do like data.set endian. Set default. Like this, right? Like I feel like this is not a terrible idea. Although I know some are opposed. Yeah. That'd be that. I mean that would be that class right there. And then you have binary view, which does have the reading. Also, the constructors can't really fail, so it does just have constructors as opposed to load functions, which I think is fine. And also important for having binary view in arguments, like implicitly. Like you know how if I have a standard string, but then I have a function that takes in a standard string view type, right? I can just pass in my string and it will implicitly construct a string view, which is really cool. So likewise, if I have a binary object, so Kojo binary foo, right? then I should be able to have a function that takes a Kojo binary view instead, right? But just pass it like this, and it should like implicitly construct it. So that'd be nice. There are also explicit load functions, but that's just like to override it. And then here you go, you have the read stuff. So you got peek, which is the main thing, and so on, so forth. Yeah, so like that seems good to me. So anyway, let's go ahead and commit this. Git commit. Make getter functions explicit, what methods? Yep. Okay. So yeah, so I guess that oh my god, so I guess that extent is fine. I'm just wondering how if I should change the API anymore. Because like Rust has, for example, Rust has a very different way of doing it. So like if I look at Rust, okay, actually I'll ask Claude to give me an example. How is reading binary data handled in Rust? Read exact. Yeah, here. So the actual types like U16, U32, they literally have these methods, which are very useful. Cursor, right? I think cursor might advance. I'm not entirely sure. Yeah. Yeah, I think bin rw is a library. But anyway, already this is quite different, right? So this one he declares a buffer, and then it says read exact. So it reads into the buffer from the file itself, which is something that C++ doesn't have, I don't think. I mean, you could do like a mem copy, but it's very, very sloppy. Not something I would want for my own API of a library that's meant to be like useful and handy. This also something I can't do because I can't just like access it from the type directly. Cursor, I mean same thing really, but I guess it's just more like here you have read exact from file. This is pretty much the same thing, just with the cursor. And you still have to pass it a buffer as well. Buff reader, like what? Bin rw. You can literally define a struct, and it will just parse it automatically. I could do this with reflection, C++ reflection, have a struct defined, then like it automatically fills it out. But otherwise, you can still do it using memcopy. Like you can memcopy into a struct, and it would be faster as well if the data is all contiguous. But as soon as you have like dynamic data, like with dynamically sized arrays and stuff, then that breaks down. Yeah, this is like a reader.read right? So like there's something. Just a thought there. Yeah, I know. What? Let me actually ask Claude then. What are some ways I could design my the API for my C++ binary library? See what kind of might really exist out there. Damn, chain calls. Yeah, bad for type safety, obviously. So what? Like, does it store like in a map or something? Magic xfbin. I mean, it's certainly interesting, just a bit fucked. What? U32, little Endian. Yeah, I mean it's interesting, but it's a no go. It's a no go for me. So it's like just like slow, and it's like a map as well. Yikes. This is cool with reflection. I know there are ways to like trick reflection as well in C++, and like there are existing reflection libraries, but it would be obviously be a lot better with the standard like built-in proper reflection compiler built in. Okay, so with static reflection, I guess the upcoming one. I mean, I say upcoming, hasn't been like finalized yet, but for this paper, yeah, just restruct. Okay. Huh? Composable functions that take a span and return a remaining value. Yeah, this is interesting. Sequence magic LE32, LE32. Or you can use a pipe operator. Piping is interesting. Magic to LE. Yeah, I know piping isn't like, it's like kind of dreaded, but like honestly, having this as a monadic thingy, it's not too crazy. I would say it's not too crazy. Not too terrible. But like this is just hard to read as well anyway. So use co-await. This is writing, by the way. I don't know. Use co-await to suspend each read. Huh? What's co-await? Is that a keyword? I've literally never heard of this in my life. Co-await. It's fairly recent, since C++ 20, it says. Suspends a coroutine and returns control. Wait, what's a coroutine? God damn. I had no idea that C++ went this explicit into whatever. Asynchronous programming. Okay, so you got automagic, co-await, read. Keep parsing logic linear. I mean, it's linear anyway. Like it should be. But okay, so like if we just remove the coroutine stuff, because it's probably not necessary, then this is basically what I have already, right? Read array of chars, read U32, read U32. Okay, that's what I have so far. Okay. Standard expected. Threaded pipeline. So read U32 int r, and then return this. Transform xfbin file, move chunks. What the hell? Man, what the hell's even going on here? That's terrible. Yeah, and like terrible nesting as well. Okay, I'll probably just stick with this then. I mean, it's very simple. Like really, just like use structs when you can to read it in structs directly, and for like dynamic data, then do something a bit more manual. And once reflection comes out, then that will make things even easier. But even when it does come out, it would still be the same like performance. So just easier to write on the API side. Okay. So sounds like a plan. I watched a video today actually that was like how to get cracked at programming, and I mean I just watch it because it's like to see what people are saying. And one thing that I've heard lots, but it's good to be reminded, is that shipping is the most important thing, right? Like don't get stuck on perfectionism. Have your thing be built and like ready to ship for users, because ultimately that's why we make software, for people to use. And if it's stuck in if it's stuck in development hell, it will never be used. So yeah, I'm gonna try to get this done. I finally have a error handling system that I'm not happy with, but like as far as C++ goes, it's the best it'll ever be. So I'm happy with it in that regard. Sorry, I say best it'll ever be, like best it'll ever be in C++ 23. Yeah. Okay, so I'm actually going to go back to my README because I have my examples here. So here I used read string. Maybe I just do read standard string. The thing is though, really it should be like const string view. But that's quite verbose, isn't it? Or even just read string view. Because like the string view is a reference to the data, and as long as the data is in scope, then it should be fine. But maybe I just leave it like that then, and I let the person choose what they want. String view kind of a size. It's a fat pointer. Okay, so I'll do that then. And then for type, here I have type abbreviations. I was thinking of having like SV for string view, but maybe that's honestly not a good thing. And I should just do this. Maybe using namespace standard string view. That's not how that works. Using standard string view, maybe. So I can do that. And then for U32, could just do uint32t, right? I don't know. I mean, like it's C++, so like I guess it's better to just use the full names. Like yeah, it's more verbose, but in the grand scheme of C++, it really isn't a big deal. And then for this, instead of including all of these, I just use like that, maybe. Yeah, I think I will. I think I won't provide utilities for this, so I'll just have it like that. So I'll use all of these globally, and then you can use them unscoped, and that'll be that. I'm trying to think, like, is there any other reason I would have this like this? Like for the floats? Well, no, because like these are standard now, so it should be fine. Like ergonomics wise, I mean, I'm aware it's also optional, to be fair. I don't know. Actually, don't know. I actually don't know what to do here. File v3. I mean, like, I know what a U32 is, so that is very clear. And like, I could have this be SV, and then I could do like stir for like normal strings. In which case, I need to add it here again. So like using SV equals a standard string view. Using stir equals standard string, right? Yeah, maybe. So git commit update example2 with type abbreviations. Yeah. There's correct flag there. What? GC. Yeah, that's actually really annoying. I don't know why GCM doesn't work as it should, but there you go. Okay. Standard endian big. Just endian big. I don't know. Could I like just like using standard endian? Big maybe. I don't know. Like ideally, like I guess this wouldn't have that, so it'd just be like this. So yeah, so like I'd add using standard endian little big and native, right? I assume that works. I can't actually remember. Let's check compiler explorer. Godbolt. Okay. Include, what's it, bits? Actually, yeah, what libraries is even in? Yeah, bits. So let's say I want to do like using standard endian big. And just replace this. Compile with C++, sorry, standard equals C++ 23. Oh yeah, I need to include higher stream. Error has, okay, so that doesn't seem to be working. Why is that? How about if I just using standard endian? That works. Okay. And this is a bool, so just wrap it. Should work. Can I actually see the output, please? 0. Oh, really? So it's actually literal by default. Okay. So that's what I need then. Cool. Yep. Okay. So forget that then. Just have this using standard endian. Whoops. Yeah. For God's sake. Yeah. Okay. Okay. So add standard endian to type abbreviations. I could also do like is it endian big? Make it like, oh my god, like just like little endian, like LE and like BE. First of all, that's really ambiguous, like LEBE, just like by itself is kind of ambiguous. But also just like, I don't even know how I would make this an alias, like an alias. Like big endian versus endian big, like the difference is just negligible, honestly. Literally 1 character difference, so no point. Right, to push. Okay. Yeah. Okay. So this is how it would go. You would load the data, have your thing here, have some errors here. Yeah, this seems like a good model to go off of. Okay, so I mean it's getting late now. It's 29 o'clock, which means it's like 5:18 a.m. But I will continue this later, and yeah, hopefully I can just get it done, so I can move on to XFBin stuff. Yep. So there you go. That's the video. Just wanted to nail that down.